So this was the last presentation of this last session. So now it's a question and answer for the three presenters that you have on the stage. If we can put Slido back on the screen. And we can get started with the first question for Airbus helicopters. How simulators can contribute to the training in case of tail rotor problem? Is the simulation good enough today? And how to improve it?
So I guess that a simulator should be able to represent the phenomenon as soon as the pedal curve is similar to that we have in flight. Now the question is, will the pilot behavior be the same in the simulator and in flight? There are some reactions that can be a bit different because one is real flight and not the other. So it should be further investigated, I guess.
So regarding the question of an uncontrolled airspace and how to assure that there is no other traffic, it is not possible to assure that. So what we offer using EGNOS is operating the same operations in IFR conditions instead of PFR. But that analysis should be in charge of the operator, and in this uncontrolled airspace, no ETS provider responsible of the separation. So if you need to develop an approach to a hospital, it's not expected that other traffic might be there, but there are lots of works in this sense in order to analyze the using IFR procedures in an uncontrolled airspaces, but there is no guarantee of that.
You can take directly the next one, which is highlighted in blue.
Yes, EGNOS can be used for takeoff, but as GNSS. So the most important benefit of EGNOS is in the approaches phase. It could be used in takeoff, but you can use the GPS signal nowadays without any problems for takeoff. So no need to use EGNOS in this flight phase. Regarding the second question, it's important to mention that we have only indeed one agreement with an operator, but there are lots of PBN operations operated by Rotorcraft in, for example, controlled airspace or whatever. It doesn't depend on the PBN capability. It depends if the aircraft or the Rotorcraft, sorry, is using EGNOS or not. If it is using EGNOS, it should be needed, the agreement, but the agreement, as I mentioned, is not a requirement. That's because we don't have maybe a higher number of agreements, but the agreement is required only with ANSPs. If there is no ANSP responsible in the environment, it's not needed the agreement, and that's because in this case, the Norway CAA required that agreement in order to ensure the liabilities and the service provision scheme, as I explained. But there is no any requirement for having an agreement with the operator. That's the answer.
So question from Airbus, please.
Yes. Are there differences between type of tail rotors, Fenestron or traditional? I would say basically it's the same problem. Then at a second order, you may have small differences because the pedal curve with a Fenestron will not be exactly that of a classical tail rotor. But the first order is exactly the same. And I will also add, if you consider an OTAR, it's the same problem. Maybe you have seen that some losses of control in you occurs also with NOTAR. Nobody dares call them loss of NOTAR effectiveness, but it's the same problem, the same kind of pedal curve and the same reason. The next one, LTE should not be considered as a malfunction in FSTD. Not only in FSTD, the classification of LT is sometimes quite strange. In a CA paper on tail rotor failures, LT was considered. This is also the case in the Rotorcraft Flying Handbook of FAA, where it is in the system failures, I think. So no, tail rotor, the LT or unanticipated yaw is not a malfunction. It is normal behavior of a standard monorotor helicopter.
So now we have the first question for you, Giuseppe. So how long will it take to have a representative model associated to one specific rotorcraft?
Okay, so thank you for the question. It is difficult to come up with a figure, but in general, I would say you start developing a model of your aircraft while you design your aircraft. So if the process is done in parallel, by knowing from the beginning that you would use the models to certify the aircraft, I think the time required to build a reliable model of the aircraft is less than the time required to build a new aircraft. So I think the time is comparable in the end, and I think if the process is managed with that objective from the beginning, time constraints is not a problem. The time to develop a model is not a problem. It's a problem to have the right tools, the right expertise, and probably to perform the right tests that are not certification tests, but are simple tests to verify the models. So you change the objective of flight tests that are not performing risky maneuvers required to go to the certification, but perform simpler maneuvers to validate the model and then use the model to do the risky job.
We can jump directly to the next question for you, which is on a clean sky and reduction in budget, I think. The one.
Okay, so we are working in clean sky because the idea is to use this way of certifying an aircraft to reduce the time to market to introduce new products. And so in the end, if we are going to accelerate the possibility to introduce new helicopters, new tilt rotors in the market, we can expect better quality aircraft with higher efficiency, and so to reduce the environmental impact of helicopters and rotorcraft. So this is why we are in clean sky.
André Michel for the two next questions.
So, is tail rotor or fenestron vortex swing state never present, usually present to some degree or irrelevant, and why? So, of course, the vortex swing state occurs in the area where the unanticipated yaw starts. So, it's difficult to say it has no effect, but it is a very local effect on the pedal curve, because as for main rotors, the way to exit the vortex swing state is to take some horizontal speed. And on a helicopter that is rotating, it happens naturally by the change in heading. So it can contribute a bit to the start of the anticipated yaw, but it doesn't make any difference when it is question of stopping the yaw, which is purely due to the shape of the pedal curve. And the second question is, could you please give us an idea of the influence of airspeed and collective position on the pedal curve? So it's quite easy, I would say. The collective position, if you increase the collective, you increase the need for anti-torque. That means that for a US rotor, as plotted in my presentation, this will shift the curve downwards, increasing the collective. The curve is shifted downwards. Reducing means it is shifted upwards. And airspeed has a different effect. The pedal curve is a kind of sinusoid, and increasing the airspeed makes the sinusoid of a larger amplitude. So, and at the limit, decreasing is the other direction. At the limit, when there is no wind, it is fully flat.
So the next question is a large aircraft community developed upset prevention and recovery tool to address the problem of stall. Relevant solution to address loss of tail rotor effectiveness and provide training material.
So I'm sorry, but I don't know this upset prevention recovery tool. How to address LTE. So I think the first point is to clear all existing documents of mistakes, inconsistencies, errors, and try, because what is given now, so the LTE or unanticipated yaw is a loss of control. So we could say that the pilot is responsible. But at the end, with the information we gave them, we are part of the crime. So we have to clear the information that is given to the pilot so that they are aware of what is the phenomenon, what they may expect when it starts, and what they have to do, and not tell them to add forward cyclic when it is not possible.
Okay, so the question is, how can you validate your simulation without having real flight data throughout the flight envelope? I'm not claiming to be able to develop a model without any flight data. So this is to clarify, we need flight data. The point is that we can perform flights to validate the models, not in the critical conditions. For instance, you can perform flight at low altitude and then use your physics-based models to extrapolate at high altitude. This will save a lot of work and time required for certification for your aircraft. So definitely few points are needed. The less, the better. But even many points, if you can extrapolate to the boundaries of the envelope, you can really save a lot of time and reduce a lot the risks. So this is the point here.
We can take just a few more questions. So one on practical one on EGNOS, and how is the procedure loaded in the GTN if the procedure is not published in the IAP?
Yes, in this case, indeed, the procedure was not published into IP. All the procedures which NLA are not published into IP. There are airline procedures. So they design the procedures, and the CAA, once the NLA gets the AOC, review the procedures in order to be used. So once all those procedures have been reviewed and validated, can be loaded in the FMS, how can I say it, to be used as would be published into AIP.
To Airbus helicopter, once the phenomenon occurred, so I guess LTE, is it possible to cancel it?
So I'm a bit afraid that I was not clear because of the question. So the answer is clear, yes. There is nothing that prevents stopping the yaw of a rotor of an helicopter. I know only of two series of tests that were done, one on the OH-58, one on the Gazelle, and in both cases, any yaw rate, even I think it reached 165 degrees per second on the Gazelle. But any yaw rate could be stopped by using full pedal. So definitely yes, and no pilot should ignore it. He must rely on his tail rotor. It is his best friend.
Yes, a question on the VTOL session. Can the flight control system AMC slide be also uploaded on the website? Yes, so if they are not yet on the website, they will be published. So our intent is really to publish everything that you have seen during the last 2 days. And I think this is concluding the question and answer session. we reach the time which we have to close. So thank you very much for all your questions and your interest in the presentation of this afternoon, and thank you to the presenters.